All right, so today we're going to be going over column storage, redefining data management for the modern era. So really quick introductions. My name is Zoe Steinkamp. I'm a developer advocate at a company called ClickHouse. They create ClickHouse DB, which is a OLAP Columnar DB. So basically it's used for analytical workloads, which is quite common for Columnar databases. So most of the stuff we're going to be discussing today is going to be about, doing those workloads more efficiently with Columnar storage. You can find me on LinkedIn. So the contents of today is, first we're going to talk about the features and highlights of Columnar databases and some of their use cases. The use cases are just going to be customers of ClickHouse because I have access to them, so it's really easy. What is Apache Arrow and Apache Parquet, and a few other Apache projects that kind of help a lot of the more modern, you could say, Columnar DBs be built. For clarification, ClickHouse is not built on top of Apache Arrow. They do have the ability to read Parquet files, but they don't use it as a storage format. But before ClickHouse, I worked at InfluxDB, which is a Columnar database that does use both of those projects. And then we'll talk a little bit about some of the tools you can use for data analytics when working with Columnar data. So who here is familiar with databases in general? Good, that's great. Who here is familiar with Columnar databases? Okay, a little bit less. The first question is the most important one, so I don't have to explain quite as much. So let's go ahead and get into some features and highlights. So first things first, this is kind of the flavors of database that we have. So I always like to kind of, explain how this works, especially because SQL versus NoSQL is a little bit confusing. So what we call relational or SQL DBs are just that. They're relational. They are row-based. They have, a unique identifier, some kind of ID row. They are our Postgres's, our SQLs of the world. They are about 70% of data storage is stored in a relational SQL database. So they're without a doubt the one you used in school, very common. They're great. There's nothing wrong with them. Then you have your NoSQL, and this is kind of a misnomer because NoSQL is basically it's a non-relational format like Columnar. It's not row-based, but NoSQL also tends to mean a non-SQL query language. That tends to be kind of another defining feature of it, which isn't always the case because there are plenty of like Columnar DBs that have SQL query language built into them. So it's a little weird when you call them NoSQL, but then you're like, but I can query it in SQL. So that's kind of where this gets a little funny. Someone even directly asked me that question. They were like, you keep calling it NoSQL, but we're querying it in SQL. What the heck is going on here? And I was like, it's, tech people didn't quite name this correctly. But this is things like MongoDB is probably the biggest NoSQL database. They're good for high throughput, large document stores, etc. You have your search databases, which store things kind of uniquely. They are a NoSQL database in that they don't store it in row format. They're a little bit more like a columnar format, but the way they do it is very unique. They tend to be very good for obviously searching data, logs, geo, just in general, those kind of use cases. And then you have columnar databases, which kind of take features of NoSQL and search, combine them together, and they get used for things like aggregation, logs, events, traces, analytical use cases, and we'll go ahead and define some of that. But basically, you can see Columnar DBs as like a more broad version of NoSQL and search combined together. So this is a pretty simple row of data. This is like a very simple row-oriented table here. You've got your unique identifier, your ID. You have a description. It's obviously a cell phone. You have a Boolean, whether or not it's unlocked, and then you have the price. This is a typical relational database query from this, which is that you're saying, hey, where the phone ID is 102, Zoe bought a phone. Her phone identifier for the order that she made on Amazon for her phone is 102. Can you please give me the price that she paid for it because she's asking for the price for, expensing or whatever. She wants to know how much she's going to pay for this, or, you're displaying these phones on a website, etc. This is very simple. This is very good. This is great for row-oriented. That's what it's for. That's why we call it transactional, is because you are asking one question and you want something back. It's also very good if you need to do a lot of edits, which we'll get into. This is how column-oriented is stored. So in this case, all of the IDs are stored together, all of the descriptions are stored together, all the unlocked Booleans are stored together, and most importantly, in this one in particular, all the price is stored together. So one thing to note is it's not uncommon with column-oriented data that you would drop that ID column because it just is not relevant anymore because you're not asking for it by row. You're really not asking for that one specific row of information. You're running analytic workloads where you're asking for the whole column of info. So for example, I want the average price from all of the phones. So the reason that this tends to end with 4 pieces of data, this doesn't fail, but imagine we have, 40,000. When you start to scale this up in a row-oriented DB, it has to go to every single row and ask, hey, the next ID, I would like the phone price. Next ID, I'd like the phone price. It's really, really inefficient. And it's not because they were designed inefficiently. That's like that. This is not a versus or anything. It's just not what they were made to do. Versus this, we don't ask for the ID, the description, or the unlocked Boolean. We don't care. All we want is that price column. And we want to go ahead and get the average for it. Which, this is the other thing too that I'll get into, is that a lot of column or DBs, or just column-oriented technologies, tend to focus on things like being able to do aggregations. They literally call it aggregate functions, statistical functions, etc. Like they focus on doing these kinds of questions. They focus on analytical queries. So here are just some examples of columnar databases and kind of like where they fall. So for example, you have Apache Cassandra, which is what I would consider probably one of the oldest columnar DBs to an extent. It's also, sometimes it's called column-like, which is a little unfair, but basically it was just invented before a lot of the more modern column-oriented architecture was created. It's open source. It's known more for OLTP workloads versus OLAP workloads. OLAP just means analytical workloads. TP is transactional processing. I know, who would have thought. So it's relatively simple. I don't like saying the full words. And then you have things like Amazon Redshift, Google BigQuery. Again, these are both SQL in that they have the SQL query language, or at least a SQL-like language. They're also closed source. You can see ClickHouse on here. It's an OLAP. And then you see things like Snowflake, which are very unique in that they kind of do both, which that's some people claim is, inefficient to an extent. Like they can do both, but that means they're not the best at either. I wouldn't say that's the case. I just think that they try to be more broad in how they handle data. And so basically, to kind of summarize all of this, row-based DBs are definitely easier to add and delete data. If you're using a columnar database on something that you need to continuously update, that's not really efficient. That's just not going to go well, which is also why a lot of people tend to use 2 databases. I know, who would have thought. They have a SQL row-based data for, let's actually take this back. Let's imagine you're a grocery store. You need to order pumpkins for Halloween, but you don't want your store flooded with pumpkins, okay? Like you need to know the appropriate amount to order. You need to know that certain stores just aren't as popular. Like people there just don't buy the pumpkins for whatever reason. So you're not just going to send, 200 pumpkins to every single store in your network. That's silly. That's not an efficient way to handle it. So what you do is you keep a row database for your constant interaction for your team on the floor. Every hour they update, how many pumpkins have sold. Really, it's automatic, but, the system says like, well, we've sold another pumpkin. So we're going to, bring down the amount of pumpkins we have in the store right now. And when we reach, 20 pumpkins, we're going to go ahead and automatically send in an order for more pumpkins. But then they use their columnar database to store, you could think about it as a much larger data set from last year where they can make analytical queries like, what was the day we sold the most pumpkins? What store sold the most pumpkins? What is the average pumpkin sale per day, per hour? And then they can go ahead and make the decision on how much they're going to order. And I know this seems like a kind of silly example, but this is used at scale. It's not just the pumpkins, it's the milk, it's everything. That you go to the grocery store, I can assure you they are doing this because they do not want to they don't want to put milk on sale because they order too much. That's not an ideal way of doing business. And this is used for everybody. Amazon does this for sure. Everyone does something like this, depending on, how advanced they get it. But it's definitely not uncommon to run something like a row database for that real-time data, that real-time updating and deleting and being like, we're all sold out of this milk. We need to order more of this. When a store person's going through and doing that on their phone. And then they have their columnar database to run the big analytic workloads when they're dealing with 200 stores and all of their information over a span of like 2 months, etc. So that also leads to ideal for OLTP. Row databases are a lot better for transactional. They have slower data aggregation. It's, again, not of their own fault. It just happens to be how it is. You have to call every single row when you want to aggregate. The columnar databases are a little bit faster because they are ignoring a lot of data. They tend to have poor compression. And I don't like saying that because it feels mean, but the reason they have poor compression is the less you compress the data, the easier it is to edit and delete it. If your data is super compressed, it's really, really hard to basically get it back out to do those edits and deletes. Obviously, columnar databases don't tend to be so transactional. They tend to be called for, one big analytic query, so they have that better compression. They also tend to just deal with heavier workloads. Like, that's just the honest truth. They tend to have a bigger data storage set. They also require more space for data. When you're doing a row database, that's fine because of the poor compression. The other side requires less space. But basically, these are just some of the ways that you can think about how these are used. So let's get into some use cases with some real customers, I guess you could say. These tend to do things like real-time analytics, logs, events, and traces, business intelligence, machine learning and generative AI, and really any application where you require what we call a real-time data warehouse, which is really just a data warehouse that you store a lot of data that you need to be able to get it back out quickly. There's plenty of data warehouses that are slow time, I guess you could call them. So, for example, with real-time analytics, Disney Plus uses us to store all of their user logs and metrics. I assume Disney Plus is pretty much all around the world at this point. Basically, it's when you want to play a movie night with your kids, you want to have a nice sit-down time, you pull up Disney Plus and you can go ahead and get going. But they are definitely logging everything that you're doing. It creates about 2 billion rows per second that they need to be able to query upon, make sure that the system's up and running, make sure things are as they expect, and also do just in general. These logs and metrics are also used to, power things like suggesting stuff for you. Like they do those like when they compare you to other people very similar to you, so they can suggest to you the next movie or the next show because they know all your history, they know all your metrics, they know how often you watch and when you watch. They know when your movie night is on Friday at 7 p.m. They know that. They see you. They've created a profile of you. And people like you, and they do it all around. This is how they know to keep producing Star Wars shows. They have the metrics to show that people are watching the Star Wars shows they produce, they're doing well, and they make more of them. And on the flip side, this is also how they decide to cancel things. This is exactly how Netflix does it as well, for sure. They're taking track. They notice when you stop watching. They know which episode you gave up on it. And you were like, I don't like this show anymore. I'm done with it. And they go, okay, so this is the part of the show where we screwed up and nobody wants to watch it anymore, so we're not going to make a second season. The next one is things like real-time analytics. So for this one, it was Cloudflare. They have customer dashboards that their customers can see basically how their websites are doing, just in general, their infrastructure. They migrated from PostgreSQL because, again, that's a relational database that just couldn't handle these analytic workloads. And when I say migrated, they're still using Postgres. To be clear, they just migrated their analytical workloads off and kept it for the wonderful transactional database it is. They now ingest about 8 million rows per second. They have a much higher query throughput. And they reduce their mean time to repair, which basically just means they notice issues a lot faster, they can repair things. I think their customers also had a reduced mean time to repair, which is great. Basically, the customer dashboard just, from what I understand, was not that great. The customers were complaining about it, and so this was a serious upgrade for everybody. This one is for observability, pretty straightforward. They were using something like Elasticsearch. Again, like I said, it's a SearchDB, great for logs, but for them, they found better cost efficiency and query capabilities with something like ClickHouse. They do about 15 million queries per day, petabytes of logs, very exciting. And then this one's just using ClickHouse as a central data warehouse. They're using it for their analytics, for their websites and apps, their company metrics, and their monitoring. So that's also something that I didn't really mention is company metrics are a big thing. You want to be able to run, workloads to determine, how much PTO people took, how much people are paid. These are all things that you have to do, for tax season or for, whatever purpose that you need to do it. A lot of company metrics are just stored in some, data warehouse where they throw everything or, in some Microsoft or Google Excel sheet, if you want to really get into it. But yeah, so company metrics are a big thing that people want to store. And again, at scale, it's very important. So we're going to do a fun little interactive quiz. So this you can do with your cell phones. I'm going to unfull screen this and full screen this. You can still also use this QR code. That should work. Do I have to do anything to get this running? I think it's running. I hope it is. Okay, cool. Perfect. Yes, if I can see names starting to pop up, then that works. And you can put whatever you want, like a bunch of letters. That's totally fine. Yeah, we'll have lots of fun here. The last time I did this quiz, I didn't realize it, but it actually has a leadership board, which is kind of funny because most people are going to get the questions right. So we had lots of leaders. All right, we'll go ahead and get this started. I think people can still join even after. So what we're basically asking is this a Columnar database workload? Like, is this a workload that you would want to put on a Columnar DB? So the first question is, analyzing sales trends over the past 5 years to identify seasonal patterns. In this scenario, a business wants to understand how sales fluctuate throughout the year to make informed inventory and marketing decisions. I kept it to a minute because this thing kind of is, but I can go ahead and skip it. I don't know who said no, because this is literally my pumpkin example, pretty much just worded better. But yes, this is exactly something that people use Columnar databases for. This is identifying those seasonal patterns. This is kind of what Disney uses it for as well, but the grocery store was a much, much better example because they deal with a lot of seasonal trends. This next one is analyzing historical weather data to support predictive analytics for agriculture. So an agriculture business wants to analyze past weather patterns to predict future conditions that could affect their crop yields. We'll let it go to the 30-second mark. This is correct. Yes, it is most definitely a good workload for Columnar DBs. And funny enough, this is actually a workload that my previous company, InfluxDB, was especially popular because within agriculture, you use a lot of IoT devices that produce basically timestamps and values. That's what the data looks like. It's just like weather and then a weather value. And so these kind of values are very good for analytical workloads because a lot of them don't even come with a unique identifier, for example, in that data set. It's really just over time, what was the weather, over time, what was the temperature, and then they can go ahead and use that to do predictive future conditions. Generating a real-time feed of social media interactions for customer service. A customer service team needs to monitor and respond to social media interactions as they happen, requiring immediate updates and real-time processing of data. Yes, it's definitely a no. I think it's funny that the yes bar is actually still like taking up most of the screen, but it's definitely a no. So the reason for this is that it's that real-time immediate updates. That's the big one. Those are the big words to keep in mind here is immediate updates. The updating of these social media posts, that's not going to be great for your analytical workload. Now, some might argue that you would use 2 DBs for this. You might do some analytics afterwards on something like an OLAP database, but in general, no. If it needs to be immediate updates and real-time processing like that, it's not going to be the best. Though, DB companies will tell you that they're the best for everything, so I'm sure somebody will tell me one day, like, no, the Columnar database is great for this, and I'd be like, look, if you look at everything as a nail and you have a hammer, yeah, everything is a nail, so it's perfect. That's how a lot of people use their tools. They're like, my hammer is perfect, and everything is just a nail. But no, there are better DBs to use for this. So the next one is generating monthly financial reports that summarize expenses by department so they can know which department is spending too much money. A company needs to create comprehensive financial reports each month to assess departmental spending. And this is a pretty normal thing. Like most companies definitely, most well-run companies definitely try to do this. Shouldn't say most companies. Yes, this is perfect for an OLAP DB use case because this is actually something I briefly mentioned, which was those business metrics. Again, this is something where you have a lot of data. You're going back possibly For this, it's only a month, but that's still a month of data. If your company's big enough, you could have a lot of finances to deal with. You got to look at your AWS bill, your marketing department spend on Facebook ads. You've got all these different people spending money, and you need to be able to go ahead and summarize these reports. Now, this one's a little interesting in that some people might say, oh, well, going to an entire Columnar database is so much for this. But remember that these DBs are also used under the hood for things like Microsoft Excel, or sorry, not Microsoft Excel, like Microsoft software that they provide for people to run these reports. Like this data can still be stored and then used by you by your, expenses teams systems. It's not necessarily you creating something from scratch for it. And then finally, maintaining an inventory management system that updates stock levels in real time. A business must continuously update its stock levels as products are sold or restocked, requiring immediate access to current inventory data. So with this one, nope. That is correct. This is what I mentioned before, where you would have one that is your analytical workload DB that is, for something more further out. And then for this one, where you're updating stock levels in real time, you're that person who has to go on the floor every single hour and say, what's been sold. Or again, nowadays, this is automated. They just tell by what people are scanning at the cash register. That level of, transactional updates and deletes are not good for a Columnar database. Ta-da! H is our winner. And the blank is our second. No, again, there's so many people here, and it only shows the top 5, and I think it does it by, I don't even know if it does it by alphabetical at this point, because blank is number 2, so congratulations to H. So let's go ahead and go back to our slides. So let's get into Apache Arrow and Apache Parquet, and just in general, Apache. So Apache Arrow is a in-memory columnar data format, which basically means that a lot of the modern columnar DBs out in the world use Apache Arrow as their in-memory data storage format. Great. You have Apache Parquet, which is a file format specific for columnar data, which can be used by anybody. It is used by quite a lot of DBs, again, as their under-the-hood storage, but you can also use it. You can literally just throw a Parquet file in S3 and be done. Then you have Apache Arrow Flight SQL, which basically allows you to transfer data without deserialization or serialization cost, as long as it's columnar format, and the tooling you're using supports it. And SQL is just specifically a flavor of it that recognizes the SQL query language. Because again, NoSQL at this point is a big misnomer. So this is straight from the website. Apache Arrow is a framework for defining in-memory columnar data that every processing engine can use. Wonderful. Apache Parquet is an open source column-oriented data file format designed for efficient data storage and retrieval. So let's really quick get into the benefit of using Parquet files when you're working with columnar data sets. So Parquet files minimize disk usage while storing gigabytes of data. Fantastic. They have very good retrieval and deserialization of large amounts. Good. They're used for OLAP use cases, typically, yes, in conjunction with OLTP databases, but even better with OLAP DBs. Basically, originally it was used with a lot of transactional databases, not a big deal. They just made them more efficient, but basically they're even better if you're using an analytical DB for the workload. Good for storing big data of any kind. I have to admit, I've only used it for like structured data tables. I've never done images, videos, or documents, but apparently you can do that too. And increase data throughput and performance using techniques like data skipping. So this is straight from the Apache website, where basically, or a website like it, where basically they're saying like they have data stored as CSV files on Amazon S3. They're talking about how much more efficient, faster, because there's 99% less data scanned, and cost savings they're getting by storing their data instead in the Apache Parquet format. Now, one thing to note is you could use compressed CSV files, which would be probably a more like a fair fight, I guess you could say. But the gist here is really not to say that CSV files are bad. The gist is just to say that Apache Parquet is just, a more modern, more efficient format for columnar data. Again, there's no like versus here. It just happens to be a bit better, especially the 99% less data scanned. So basically, when you go ahead and store data into your Parquet files, it creates things like page headers and file metadata. And the file metadata is the really important part because it basically says what data is inside the file. So this especially is, it tends to be like a timestamp format where basically it says each file is storing 1 day or 10 days worth of data. And what that allows it to do is skip the files when you're asking for something like, hey, I only want the expense report for the past month. That means it does a very obvious algorithm. It goes in and it goes, hey, if it's not, if it's before this date, I don't want to read those Parquet files. I don't need them. It's before this date. If it's after this date, I don't want to read those either. And then it grabs the chunk of files that are what you actually desire. Very efficient. That's what they are meaning by data skipping. So yes, it will not scan the records that don't meet this requirement. So basically it's saying, I don't need to read those. That's not what's, that's not what's relevant. And I'm using date because it's kind of the most common one. People could also do something like an amount, but that would assume that your column is sorted by amount, which you can do. People do it. They basically sort their data before it goes into the file systems, and it's a whole thing, but most people, it tends to be based off of date. That just is a more obvious way to handle it. And again, with analytical workloads, normally if your query is like average price of cell phone, the next question after that is like average price of cell phones today or this week. That tends to be not too far off. Secondary is to use a date. The other thing is that they take advantage of dictionary encoding. So this bottom example is basically how ClickHouse does it as well, which I'm using because it's just a little bit easier to read and understand. But basically, the gist here is that it is more efficient to store a number than it is a string. It's just straight up smaller. The other thing is that it's better for encoding, and it will improve compression ratios. So basically with the ClickHouse example down here, you can see that we're defining weather with a number. So basically if it's like a normal weather day, it equals 0. If it's, a snowy day, it equals 18. And that's what we store. Instead of storing something like unknown precipitation, which is obviously a much longer string, requires more, just more in general compute to store, we're going to just store it as number 19 instead. This basically also allows it a little bit easier to be able to actually go back and get it out. So this enables those algorithms. This is something that Apache Parquet can do, which is, again, very good for analytical workloads. ClickHouse is not the only one who does something like this. Most Columnar DBs do. So in general, people choose CSVs for simple exploratory data. Great. They choose line delimited JSON for anything more complex or nested data. They use Parquet for their larger data or stricter schema requirements. This is kind of, you could say, like the road that you go down to get to eventually using Parquet within your system. And then they use a data catalog plus Parquet for data warehousing. So that is like Snowflake, Databricks. That's what they're doing. They're using something like the Iceberg data catalog with Parquet for the actual file storage. Totally normal. That's like not for you necessarily to set up, though you could do it. But that's more for like, okay, now I'm going to put my data in Snowflake. That's what they're doing under the hood. So this is a funny little meme. It's basically saying like, hey, the boss just asked if we can build support for reading our Parquet files. And it's basically saying that in the past, you would have needed to do your own like vectorized delta encoding, deserialization, decompression, all this jargon here basically is just saying that before Apache Arrow in particular, well, more particularly Apache Arrow Flight, it was quite the nastiness to actually be able to read Parquet files because there just wasn't like an obvious way to do it. Nowadays, there's like 200 plus tools that can do it, so it's great. I'm so glad everyone's taking advantage of Apache Arrow and we don't have to deal with it. But basically, why Arrow was originally invented. So when we talk about Arrow, we're talking about the in-memory data format. The Arrow Flight came after, though not very long after, to be fair. They were basically kind of being created at the same time. But the reason Arrow was originally invented was that businesses needed, more requirements for analyzing and using data with higher standards for query performance. Basically, they're saying people realize Columnar DBs are really good for these analytic workloads, and wouldn't it be great if there was more tooling and more, better formats for them to store it in? Memory had become inexpensive, enabling a new set of performance strategies based on in-memory analysis. CPUs and GPUs have increased in performance, but also have evolved to optimize their processing data in parallel. There was lots of new databases. There was new disciplines, including things like data engineering and data science, which really hadn't been a thing until the past, like 10-ish or so years, I want to say. Before then, yes, they existed, but it's become definitely more of a boom recently with dozens of like new tools and stuff. And columnar data representations have become mainstream for analytical workloads because they provided dramatic advantages in terms of speed and efficiency. These are some of the lead developers from about 14 major open source projects that were involved or still are involved in Arrow. They don't normally say whether or not they still are, but they definitely were involved at one point or another. And you can actually see on the second one is Apache Cassandra. So some of their engineers helped with this as well. And the Parquet team and the Pandas team, which is why Pandas had pretty much the first, you could say, like implementation of Arrow flight. So the benefits of it is that it's language agnostic. Specifically, it supports a wider range of languages, including things like C++, Java, Python, and R. It's efficient for running analytical workloads on modern CPU and GPU architectures, which this is kind of showing here, but basically it's just saying that before you would have even your columnar DB data stored in like a traditional memory buffer, and it just wasn't that efficient, versus now you can go ahead and use something like this, which is more efficient for modern CPUs. I'm going to be honest, I don't understand all of the under the hood as to how this is so much better because I don't understand fully. I suppose you could say how CPUs work. It's a bit deep for me. It's not quite where I focus. I focus on the database layer. The CPU layer is a bit more below that. But from what I understand, it's just really more efficient, and this is how modern CPUs are made to handle those kind of algorithms, those kind of queries, and this kind of data storage. So the way that it's now done within Arrow memory is much better. And if you want to look more into this, basically, see somebody who did some benchmarking about this. For example, with this file size, you can see they're using in number 3 here, the Arrow Parquet file. And with those two combined, you can see that the file size is quite smaller. They also do a bunch of other graphs on things like reads and writes and speed. I just couldn't fit all of it in this slide. So if you want to take a look at this kind of benchmarking, you're welcome to, grab that link there. But you can see others here like Feather, DuckDB, just a database with YAML, a database classic, etc. And in general, the reads and writes were a little bit more impressive, but this is still pretty cool. And you can also see the most inefficient here is Arrow with a CSV file. Poor CSVs, they get no love. So finally, Apache Arrow Flight and SQL Flight. So Apache Arrow Flight is defined as a new client-server protocol developed by the Apache Arrow community for interacting with SQL databases that make use of the Arrow in-memory columnar format. Wonderful. Basically, that sentence right there is so great for confusing everybody. Because when they say SQL databases, they really mean columnar DBs that have SQL capabilities. They do not mean as much relational databases like Postgres and SQLite or anything like that, though they can be used as well. But obviously, you need to also be able to read the Arrow in-memory columnar format, which means you're basically a columnar database, which, yeah, like I've said before, this is all kinds of funniness. But the gist here is that Arrow Flight helps do high-volume transfers of column data. Wonderful, which is great because, again, when you're running analytical workloads, you are probably moving your data all over the place. It just kind of comes with the territory. They are good for distributed computing and analytics. Basically what I just said. The Flight SQL version is pretty straightforward. It's basically just Arrow Flight with a query execution for SQL. So they are expecting you to query the Arrow Flight with SQL, with a SQL query, totally normal. One thing to note, though, with Arrow Flight is it's agnostic. So that also means that, like, for example, at Influx, they use it with their own query language called InfluxQL. There's a few others that I can't think of off the top of my head, but basically, if you're a DB and you've got a query language that isn't SQL, but you're also column-oriented, you can still use Arrow Flight. Wonderful. So before, this is kind of how things would work. You would copy and convert and copy and convert. It was not the best. It was kind of inefficient. It kind of sucked, to be honest. That's the nice way of putting it. And this is between all of these wonderful tools that lots of people like to take advantage of, because also in general, as many people know, in technology, we tend to accumulate technical debt. So basically, somebody started using Cassandra, and now Cassandra is ours. And even if we wanted to move the data to something like, like ClickHouse or something, we're still going to have Cassandra with us. And somebody wanted to use Pandas, but somebody else wanted to use Apache Spark for whatever. And next thing you know, you have like 20 tools that you're using, and you need to support all of them. And so that's part of what Apache Arrow kind of came in and did, is it was like, hey, we're all great, we're all wonderful. Well, really, it didn't actually care, I suppose you could say. But in theory, it was like, we're all great, we're all wonderful. Let's all work together. And by work together, we mean like, can we please like read a Parquet file from DuckDB to InfluxDB to Pandas to Apache Spark, et cetera? Like, can we please just make life simpler for everybody? Let's stop making our lives any more harder than they already are. So that's basically what it allowed it to do. And the big thing here is that there's no serialization or deserialization cost when you do this direct data transfer. So whenever you're sending data between, and by the way, there's so many other technologies that take advantage of this. It's just that these were the easiest to find, like their logos were the easiest to grab. But there's, I think, like over 200 technologies, bare minimum, that are taking advantage of Apache Arrow that you can use to transfer data. And yeah, because you don't have that serialization or deserialization cost, it's much more efficient. And again, you have to keep in mind, with analytical workloads, efficiency is like key. It's part of the whole reason that people take the time to move a bunch of data to something like a new database, because I can assure you, moving DBs is not fun. It's not easy. It's really not the best. Like, nobody wants to do it. You only do it when the pain point is high enough, and then you have to start working with all these other tools and all this other stuff, and it's so nice if you don't have to do like serialization, deserialization cost when you start using those new tools. So for example, this is with somebody reading a, so PyArrow in this example is the Python Arrow project. Basically, it's just, a project that can use Arrow. And so with this one, they're reading a CSV. They're reading it without PyArrow, and they're reading it with PyArrow. And with PyArrow, you can see the CPU times specifically are going down, and you can see the wall time is significantly decreased. So this is great. This is just showing that it's so much more efficient to read the CSV file with something like PyArrow instead of just pure Pandas. And remember, Pandas supported this project. It's not like we're saying Pandas is bad. It's just that with PyArrow involved, it's just so much more efficient. And I would be remiss if I didn't also talk about the Apache Data Fusion project, because I worked closely with the guy who's maintaining / basically taking care of it, and also, getting it all these awesome new features. But basically, it's an extensible query engine written in Rust that uses Apache Arrow as its in-memory format. So it's taking advantage of Apache Arrow. It aims to be the query engine of choice for new, fast data-centric systems, such as DBs, data frames, machine learning, et cetera, that want to leverage things like Apache Arrow and obviously be column-oriented. So all of these DBs and technologies on the right-hand side are taking advantage of it, which also means they've all basically been created within the past 4 years. Or, well, I guess 5 or 4, somewhere in that range. And then I just kind of wanted to show this slide so that we could kind of understand this. So for example, InfluxDB was built with the Apache Arrow memory format. They've got Apache Parquet as their file format for storage for when they store their customers' data. And then they're taking advantage of Data Fusion so they can have a SQL query engine. So this is, again, why things have broken down when it comes to NoSQL versus SQL, is all these new technologies here can basically write in SQL because of the fact that they've got the Data Fusion engine. And then they're using the Apache Arrow Flight SQL to build out their client libraries, which are basically just RESTful libraries in the language of your choice. And then they use that to go ahead and send data onward to other tooling. So things like Plotly, Apache Spark, Tableau, Grafana, et cetera. All of this basically is powered all with the open source Apache Arrow project. And obviously, every single technology kind of picks and chooses what they want to, take advantage of. Like I said, ClickHouse is not built under the hood like this, but they have an Apache Arrow, basically data transfer protocol, so they can do the data transfer. They have Apache Parquet as a readable format. So if you have your data stored in Parquet, they can go ahead and read it. But again, it's just up to the technology provider. So I wanted to really quick mention some tools for data analytics, tools that people tend to use for data analytics. And one that I really quick wanted to mention here was Pandas. But I actually had a really interesting conversation with a data scientist where they were basically like, we don't really need to use Pandas as much anymore because all of these column-oriented DBs have their own SQL functions, their own aggregate functions. They're like, they weren't using ClickHouse, they were using DuckDB, but they were like, I don't need Pandas so much anymore. And I kind of wanted to show that because that was not something I hadn't heard before, but it was interesting at how blunt they were, you could say. But for example, here's some of the aggregate functions that ClickHouse supports. And you can't really read these slides. Here's some of the SQL aggregate functions that InfluxDB has, for example. And I'm going to be honest with you guys, I'm not a data scientist by trade, so I don't know what all of these do. I have an idea for some of them at least. I've done correlation and stuff, but I have not used all of them. Then you have things like your DuckDB functions, which, yes, have quite a lot of functions built into them. And basically their argument was that Pandas has now become a underlayer. Like it powers a lot of this, but it's not necessarily required anymore. Like you don't have to use Pandas for your analytical tooling, which I thought was interesting. Another one is CHDB, which, funny enough, is kind of like a competitor to DuckDB in a way, but basically it's an in-process SQL engine. It's powered by ClickHouse, but it's agnostic. You can use it basically with any like any of your analytical workloads. It just happens to have ClickHouse as like the under thing, because ClickHouse is open source, so people can use it and build upon it. It also has input and output supported with Parquet, unshockingly, and supports things like Python, etc. I'm running out of time, so that's kind of why I'm skipping through stuff. And with this, you could see how querying Pandas data frames with CHDB is about 87 times faster. This is an article that goes into it. The other one I wanted to mention is Telegraph, which is an agent for collecting, processing, aggregating, and writing logs, metrics, and other arbitrary data, which is really common for analytical data. For example, these are some of the categories of Telegraph plugins. Telegraph is amazing for collecting data off of any of these kind of sources, and that's why it's so popular. It's fully open source, and it has about 400 of these plugins, so you can definitely take advantage of that if you're dealing with analytical data. And for some final resources, this is the ClickHouse community. So if you ever want to, reach out to me, I'm on our Slack, etc. If you want, to check out ClickHouse a little bit more, which is obviously an open source Columnar database, which is kind of what this whole talk has been about. And yeah, this is our academy where you could learn more, basically. It's just where we keep all of our workshops. And yeah, thank you so much for coming to my talk. I hope you learned something. And if not, well, there's more talks today.